Yeah, but that's not yet.
Peter Piper picked a pack of pickled peppers.
I believe that's the opening statement to the video. Hi, welcome. I just remembered that I should record this for you. So far, what we did is we were given the derivative, we integrated to find the original, and now we're using the clue to substitute back in and find out what C is. Okay. Yay! So then now, don't forget that you need to put the constant in there. And then you have the original, okay? All right. We are going to look at example 2. Example 2 says,
I'm being pulled.
Jason, can you read example 2 for us?
Absolutely.
Okay.
Find f of x given that f double prime of x equals 2x. And the points 1, 0, and 0, 5 lie on f of x.
All right. So these are our clues, right? You're on the right track.
That's the end, though.
Yeah.
Right now.
So check it out, right? So we're given the second derivative and we want to get to the original. So that means we're going to have to integrate how many times? Okay. So watch what happens when we integrate first and then integrate again. Okay, so we're going to integrate first to get to the derivative, right? Is what?
The silly snake is the integrator.
It's summing. It'll make a lot more sense when you do definite integrals, okay? So just hang in there. The S and the dx differential will make a ton more sense when we get there. But for now, we're just doing the basic scale, okay? Good questions, though. So now I've got 2x to the first plus 1, divide by the new exponent. And use your notation to keep track of your work. And then don't forget, what's this new guy's?
C is -1.
Hold on. So since I'm integrating again,
No, I don't.
I'm going to name this C naught, okay? Because I'm going to end up with another seagull. I'm going to end up with another C. So I'm going to have the derivative.
I used to want to pass you
What? Yes. No, me too. I'm not even kidding. We tried to catch one when we were kids. Like all the time we were trying to catch them.
How did you not shoot it?
We would put dental floss around snacks and like try to catch them. We never did.
You just grab it.
What?
Just okay.
We just go to Hamlin and Darwin is just there grabbing birds. Like what? I don't think I could ever catch a seagull by hand. Okay, so now, how do we get from the derivative to the original?
We do it again.
Do it again. Now watch what happens when we integrate this guy, right? Yeah. So I would have x to the third over 3 plus this guy gets an x when he was a constant, okay? So that's kind of new. And then now we have another constant being introduced. Let's call him C1. I would prefer to call him seagull, but that's too much to write. So now, there we go. So now this is the original. Uh-oh, I have 2 unknowns, but I have 2 clues, right?
Yeah!
Take a second and think. Which clue would be most useful to use first? Why?
Because that's why.
It's going to make the x's go away, right? So let's start with that one. So we're going to start with this one, okay? So I would have 5 equals.
Well, can't you just infer that it's C1 because that's the y-intercept normally?
Yeah, I mean, like that's where the math will take us. But we're just showing everybody right now.
I need to see it to believe it.
Yeah.
I want to see you sleep. What?
Repeat it for the class.
Right? So like that's what you were talking about.
I'm gonna slime it.
Okay, so then now let's find the other one. We've got
I think we had 100 on our test.
Really?
Really, I don't believe you.
So now let's use this one, okay?
You're gonna be confident.
Her test was sad.
Well, the first page was good. Well, the first page was sad. The second was better.
You know who Ursula is?
I don't know how much of a compliment better than sad is.
Yeah. Yeah, actually, now I'm seeing it. Yeah, I think we got like a 2.
It's okay.
I don't think so.
Bad, then it's sad, and then it's bad, then it's anger, then it's sad,
Oh, wait,
then
hold
it's
on.
disappointment.
Yeah.
So we're right above Did you this. grade ours yet, Miss Felton?
Yeah, so it's even terrible.
Hmm?
It could, it's
No,
not-
I grade everything like I do it all at once. Do you know what I mean?
No, I don't know.
How many tips explain?
Like I do like one page at a time for everyone, and then I go to the next page. It's just faster. Okay, so I have a negative 16 over 3. I'm gonna put it all together. Are we ready? We got it all together.
I'm ready. Get me out.
F of x equals x to the third over 3 plus. Oh, sorry, C naught is a minus. Minus 16 over 3 x plus 5. All right.
It's a lot of fun.
You're just working backwards. Look at all this weird notation, you know. Isn't that fun? Sometimes you ever just look at your math and you're like, whoa.
This sucks.
That's the spirit. All right, let's go to question number 3.
Alien bacteria, I like this one.
Who has the pen?
A population of alien bacteria is growing in Jack's backpack at a rate of, okay, pay attention. They're giving you the rate function. What is this a sneaky way of, what is this a sneaky thing?
F prime X.
Yes, this is the derivative. Good job. They gave you the derivative function.
Is this a true story?
How did you know that? The rate. About alien bacteria growing in Jack's backpack? Yes, 100%. Where
Probably like get some.
where T is time and days since the rover landed in Jack's backpack. If the initial bacteria population was 100, what does initial conditions mean?
0.
Who 0? Good job.
You're stealing my thunder, man.
Thunder stalling.
Okay, so now it says find the population as a function of time. So P of 0 equals 100. That is our clue. We were given the rate function, aka the derivative, and we're trying to get to the original. So let's go ahead and integrate the rate function. Okay. Now let's think about this guy, right? When we're taking the derivative of e to the t, what is it?
Itself.
What if there's a 1/4 in the front?
Then it's the same thing. So.
We just kind of add that constant on at the end, right? We just multiply at the end. It doesn't really make a difference, right?
So this
Factors,
doesn't change.
yeah, constants can be factored out, right? So if I have a 1/4, or if I have an e to the t over 4, if I separate that 1/4 out in the front to be a constant, it makes it like easier for me to see what's going on, right? So now, if I were to integrate this, I'm just like, oh, okay, the integral of e to the t is e to the t times 1/4 at the end, right? And then now if I wanted to do the next piece, it would be negative 2t to the third divided by 3 plus Connor the Seagull. And this is our original.
I love you, Connor the Seagull.
Connor the Seagull, we love you. Darwin can catch a seagull with his bare hand. I can't.
I didn't catch anything.
That's crazy.
Is it always one?
What?
Catch a Yahoo?
Zero is always one, correct?
What is
E to the 0 is always 1.
Oh, the Yahoo.
I just created a test where someone didn't do that, and I was like, no!
Name drop.
I don't remember who it was.
That's
Yeah,
That's also why I grade page by page, so I don't get filled with rage.
What?
Then it's like anonymous, and I could just get mad at the collective and not individuals. Okay, so now I'm going to So now I get to plug in the clue.
Now it's now.
You should have seen his face when I turned my unity test. You had no idea.
All right, so what do we got here? Take it away, cowgirls and cowboys. What do we got?
400.
1 4 plus 2. No, 1 4 minus 2.
What?
No, it's a 0.
Whoa, I'm an
What?
idiot.
What?
I'm just like I was raised in a barn.
4 equals C. That is
99.75.
I'm just.
Don't do it like that. No.
There should be nothing. This is a grown man, by the way.
Fuck nah. No.
What does Jack always say?
F word.
TSPMO.
Yeah.
That's right. How did you get 3
I don't like that.
I'm a genius.
Don't talk to my mans like that.
Period.
Hey, I'm screwed. You know the style?
All right. So now we've done a few like little trickier ones than the ones that you just did for homework that were just straightforward, like calculate the integral, right? I do want to go over some of the skills that were covered in the homework last night, okay? So let's go back and just kind of get an overarching view of some of the tools that might be useful in your toolkit moving forward, okay? So we're gonna work from the top down. This one, pretty straightforward. This one, what did you do when you had 1 over something in the denominator? What did you rewrite it as? Right, because it helps you use the reverse power rule. Think about the ways that you rewrote things so you could use the power rule. You use the same types of rewrites and thinking to rewrite things in a way that you could integrate with the reverse power rule. Does that make sense? Yeah. What did you do for this one? You rewrote it as something you could take, yeah, you could use the power rule with. This one's pretty easy.
Wait, where did the 2 come from?
Where?
And,
I got 3 over 2 as my new exponent, and then division by 3 over 2 is the same thing as multiplication by 2/3. So, I feel like Miranda asked me a question that I wanted to.
I said, something about the constant.
Oh, yeah, okay, I could explain that one to you really quick over here. Okay, so Miranda was like, if I had something that looked like this, so it's the same thing as this one over here.
Straight jacket.
So, if you ever find yourself in a situation where you have a polynomial that you would like to break up for whatever reason, right? Sometimes you have like tricky things in the middle or something and you want to break it up. It's totally okay to break up an integral like this, okay? 3x squared dx plus the integral of 2x dx. Do you guys see what happened here? They each got their own differential, and then you rewrote a new symbol here. You kind of broke each thing up, okay? Then what you could also do to make your life easier is you could factor out the constants. So like in this case, we've kind of just made it a little more difficult for ourselves, but this could be useful if you were doing it a different way or something. Okay? So these are all acceptable ways to break up an integral. Does that answer your question kind of?
Yeah.
Okay. So let's go back to looking at our skills, right? Okay, the rest, these were pretty easy. This guy's just a straight polynomial. Okay, look at the red star. The reason why I starred this one is because this is just like when we were first learning how to take derivatives, and we didn't know about the quotient rule yet, right? You guys don't know about the equivalent of the quotient rule in integrals, right? So how could you rewrite this guy so you can use the power rule? Do you remember?
X minus 1/2 times 1. So.
Kind of. You can you separate them. You can split up the denominator. Is this like inklings of what we were going to say, perhaps? Yeah, right? You could split up the denominators. So go ahead and write split up denominators. This is a skill that is also available to you. So we talked about pulling out constants. Now we're talking about splitting up denominators, okay? You guys don't know how to do division of stuff, right? So you would rewrite it in a usable version. So you would have x over the square root of x plus 1 over the square root of x dx. And then do you kind of remember these now, right? When you have division of like bases, you subtract the exponent. You can rewrite the second piece as x to the negative 1/2. Yeah? Okay.
It's the win, bro.
Where? Yeah, right here. Because he was in the denominator, yeah? And then you could just use the reverse power rule to go forward from here, okay? So you see fractions, splitting up denominators is available to you. What about in the ln one? This guy. Let's look at him over here isolated. You look like one of those bodies in a haunted house, and you think it's just like a bag stuffed with hay, and then it moves.
Maybe I'm just
That's
short.
how you're sitting right now.
No, this is how I sit. I'm just short.
Listen to
Are you
this
making
one,
fun?
Jack.
Now you sound like it too.
I'm just short. Are you making fun of the short people?
Ooh.
Okay, so now let's talk about pulling out constants. Look at the first term over there. You have negative 2 over x. What should you pull out to see exactly what's going on there? A negative 2, right? You want to do that? And then I'm going to split up this guy. Let's pull out the 3. Oh, now it's like so easy. Now I see exactly what's happening, right? Do you guys remember what 1 over x, when you integrate 1 over x, what it becomes? ln of the absolute value, right? Good job. Why does that happen? Think about it. If I had 1 over x and I wanted to rewrite the reverse power rule, I would have something like this, right? If I try my rule, what happens? Add 1, divide by it.
Oh no. You can't.
This is like a math dumpster fire, right? We don't want to do that. So instead, when you integrate 1 over x,
Overnight.
the ln of the absolute value of
But I see
x.
it adds
Okay? Because that's basically like the one exception to the reverse power rule. Okay? All right, so now this becomes way easy. You're like, oh, negative 2 ln of the absolute value of x plus 3e to the x plus c. Okay? So that's pulling out constants. And then this one is also pulling out constants with an ln, so it's kind of the same thing, except in this case, the 4 is multiplying everything in here, so I wouldn't split up each individual polynomial item in the integral. I would just pull a 4 out and then integrate the string inside the way it is. Okay? All right, cool. Let's play Gimkit. Do we have time? What time is it? Can someone tell me what time this set ends?
30.
30.
Oh, yeah, we can play Gimkit.
Why is it so hot? That's what? Oh,
Bye, everyone. We're playing a Gimkit.